In this video, I'd like to talk about the concept of the coordinate plane, or specifically the XY plane. And this idea, this concept, is one of the most important in human history. This invention essentially united algebra and geometry. In fact, this was invented in the mid 1600s by the philosopher and mathematician Rene Descartes. You might be familiar with his famous saying, I think, therefore I am. But he's credited with inventing this coordinate plane because the story goes that he was lying on bed and watching essentially a fly travel along on the wall, and he realized that he could plot where that fly's position is based off how far they are left or right and how far they are up or down. And he can actually put a number towards that. So the idea is that if we want to plot points, then we can use this coordinate plane system to know exactly where they are. So let's say this point right here, we always write the x value first and then the y value. This is just convention. It's a human idea, but humans decided that x should be first and then y. So for us, for this point, it looks like we go to the right 4 units. That's our x value. And then we go up what looks to be 6 units. So that would be our y value. And then if I kind of flip the question around and say, where is the point -2, 5? Remember, we find the x value first, then the y value. Whereas x is how much we go left and right, and y is how much we go up and down. So we go -2 to the left, that's here, and then we go up to +5. That would be right there. So that is the point -2, 5. And you'll notice the scale on the coordinate plane. I just counted by ones, so 1, 2, 3, and so on, and same with up or down. If you go to the left of 0, you get the negative numbers, which count upward in the negative direction. And essentially, we have 2 number lines on top of each other, and these number lines are at a right angle, or a 90-degree angle. And the choice of the scaling is really up to you. For this particular problem, I chose to scale it where each dash mark is just one more, but you can choose whatever you want just as long as you're consistent. Like I could have done 5, 10, 15, 20. I could do 10, 20, 30, 40. You just don't want to skip. You don't want to go from, let's say, 20, 40, 60, then 100, because that wouldn't work. Now you're kind of cheating. Between each of these, you only added 20, but then between the third and the fourth one, you added 40. So this would not be an appropriate scale. Now, with all of this in mind, let's look at some different example problems. So in this one, we want to use the coordinate plane to plot the points or to label what each of these points is. So let's start with A. And remember, we always want to start with the x value first, then the y value. So the x value, which is how much we go left and right. In this case, for A, we go left to this point here. And it looks like each dash mark is a half. So this is -0.5, -1, -1.5. So if this is -4, then this is at -4.5 for the x value. And now we look at the y value, how far down we went, or in some cases, how far up. And in this case, it looks like we went down to this y value of -3. So A is at the point -4.5, -3. Now let's look at point C. It looks like C has an x value of +4 and a y value, it goes up 1. So x value first of 4 and then the y value of 1 for second. And now point B is a little bit trickier because in terms of going left or right, we actually didn't. Notice that an x value here, this is an x value of 0. In fact, any point along this y-axis here has an x value of 0. Just like any point along this x-axis here would have a y value of 0. So for B, the x value is 0, and then it looks like we go up 2 units in the y direction. So B is at 0, 2. So moving on to this next example. So this one's essentially the opposite type of problem. you'll start with these points and you have to drag them to the correct coordinate. So for this first one, we have 0, 6.5. So remember x first, then y. So 0 in the x is along the y-axis and then up to 6.5. So that would be that point right there. That is 0, 6.5. Now moving on to the next one, we have, let me use a darker color. Let's say 1, 9 next. So we go over 1 and then up 9. So that would be right there. So that's 1, 9. And for this last one, this minus 5, we go minus 5 in the x and then down minus 5 in the y. And they would meet right here at that point. So that would be minus 5, minus 5. So moving to a different type of problem. Now we want to know for which points is the x-coordinate less than positive 3. So we're going to find an x-coordinate of 3, and we're looking for any points that have an x-coordinate less than that. So basically what I'm going to do is draw a line at x equals 3, and any points that are to the left of this would have x values less than 3. For instance, C and D. D has an x value, it looks like, of minus 2.5 and a y value of minus 1.5. So D works. Its x value is less than 3. And for C, it looks like it's at an x value of 1 and a y value of 1, so 1, 1. But its x value is also less than 3. Whereas for A, its x value is 3.5 with a y value of 1.5. And B, it's got an x value of 4 with a y value of minus 2. So you can see that A and B have x values greater than 3. So only D and C for this problem. And number 4 is very similar, but now we're talking about the y-coordinate with values less than minus 1.5. So now we're on the y-axis at minus 1.5. I'm going to draw in essentially that dashed line, and we're looking for values less than that, or essentially more negative y values. D would have an x value of 1.5 and a y value of minus 2. Minus 2 is definitely less than minus 1.5, so D works. And B is at the coordinate minus 4, minus 4. And since minus 4, its y value is less than minus 1.5, B would satisfy the question as well. So in this case, B and D are the answers. And lastly, we have this problem number 5 here. Which ordered pair is not graphed below? So essentially for all of these, I'm just going to go through and check to see if we have a point there. So minus 4, 4, so minus 4x, 4 for the y, so that would be point A. So that one's fine. And then 0, minus 4, so 0 for the x, minus 4 for the y, that is point B, so that one's okay. And then minus 4, 0, that would be this point right here. Minus 4 for x, and then no up and down for the y value. That point is not graphed. This point over here of 4, 4, that's D, that one is graphed. So C is the one that is not graphed below.